So this is number properties. This will go on page 104. After we fill it in, we'll cut it out and glue it, but I wanted us to be able to write on it first. So the number properties are what we talked about yesterday, the commutative property, associative, identity, distributive. And so this is just going to be a little foldable you can use to help you. So let's start on the left, where it says any number added to 0 or multiplied by 1 is the same number. Guys, this is going to be the identity property because you're getting out the same number. So it's like looking in the mirror and seeing the same thing. So your examples are 4 plus 0, that gives you 4, and 4 times 1 gives you 4. If you notice, this is only with addition and multiplication, not subtraction and division. There's nothing you can do to subtraction and division to give you the same answer that you started with. Yes. Yep, if I write it, you write it. Okay. The next one. The order in which 3 or more numbers are added together or multiplied together does not change the end result. This is going to be the associative property. So your examples are 2 plus 5 plus 9, and if you notice, 5 and 9 are in the parentheses, and it gives you 16. But then they switched around the numbers, 5 plus 9 plus 2, and it still gives you 16. So when you can change them around with adding and multiplication, it doesn't matter. They're all going to be multiplied together. They're all going to be added together, and it should give you the exact same answer. So the bottom two, 6 plus 4 plus 8 is the same thing as saying 4, hold on, let me make sure I do it right. Yeah. 6 plus 4 plus 8, because now we would add 6 plus 4 first instead of 4 plus 8 first. Okay, below that is 4 times 5 times 9. That's the same thing as saying 4 times 5 and then times 9. And then I really like that last example they give you, 4 plus 2 plus negative 2. And then 4 plus 2 plus negative 2. It's the same thing. They just changed the parentheses. But I like that negative in there. All right, let's look at the one below that. Any number multiplied by its reciprocal. Underline the word reciprocal. Reciprocal is the opposite, the flipped. So if you had 1 over 2, the reciprocal would be 2 over 1. And you're multiplying by the reciprocal, and that should always equal 1. This is the inverse property, because inverse is opposite. So for example, you find the reciprocal of whatever number you're being given, which means you flip it and then you multiply the fractions. So our first one is 2 times 1 over 2. Guys, that is the same thing as saying 2 over 1 times 1 over 2. Multiplying fractions, that's no problem. That's right. Top times top, so 2 times 1 is 2. Bottom times bottom, 1 times 2 is 2. And 2 over 2 equals 1. So what would be the reciprocal of 3 over 4? 4 over 3. So we're going to multiply 3 over 4 by 4 over 3. Whoops.
That's 4 over
4 over 3. Multiplying fractions, that's no problem. Top times top and bottom times bottom. So 3 times 4 is 12. 4 times 3 is 12. And 12 over 12 equals 1. All right, let's move to the top right. The order in which two numbers are added together or multiplied together does not change the sum of the product. That's the commutative property. So it's like you're saying you're all part of a community. It doesn't matter who lines up first, who lines up last. You're all still part of the same community. You're all still going to be in the same part. So, for example, 2 plus 5 is the same thing as saying 5 plus 2. So what would be the same thing as 3 plus 2?
3 plus 2 is 2 plus
2 plus 3. What would be the same thing as 5 plus 7? 7 times, I'm sorry, I said 5 plus 7. 5 times 7 would be 7 times 5. Because they still give you the same value. They both give you 35. All right, so the next one is 17 plus 8 plus 3 would be the same thing as 17 plus
3 plus 8.
plus 3 plus 8. 5 times 8 times 2 would be the same thing as saying 5 times
2 times 8.
times 2 times 8. That's a commutative property. All right, let's go down one. To me, this one is one of the most common that you will use more often in higher level math for sure. Multiplying one number by the sum of the two numbers is equal to distributing the multiplication to both add-ins before adding. So typically, if you were to see 5 times 4 plus 2, you would say 4 plus 2, right? Okay, that would be 6. Then you would do 5 times 6. Guys, it's the same thing as distributing whatever is on the outside to the inside, because everything inside that parentheses is saying multiply it by whatever's on the outside. Because we know that a number next to parentheses means multiplication. So distributing it, it's going to give you the same thing. So 5 times 4 plus, I'm going to highlight it. Whoops, nope. Plus 5 times 2 so the bottom, 4 times 20 plus 3, that's the same thing as saying 4 times 20 plus 4 times 3. Because when you get into higher level math, you're going to start having variables there, not numbers. So you're not going to be able to say x plus y equals something multiplied by 4. So you have to distribute. Okay. 6 times 30 minus, it's not always plus, 6 times 1. And that last example is really, really cool. So for those of us who maybe don't really like multiplication that much with decimals, you can actually kind of work backwards. So 99 cents is really, really close to $1. So we could say 8 times 1, which is 8 times $1. But if we do that, then we're going to have to take away the difference, which would have been a penny. So then we would have to say 8 times 0.01, which would just be 8 cents. All right, in our last example, any number added to its opposite will equal 0. This is the inverse of addition. The other one was the inverse of multiplication. This one's the inverse of addition. All you have to do is change the sign from positive to negative or negative to positive. So, for example, 5 plus negative 5 equals 0. Those are additive inverse. Negative 4 plus 4 equals 0. Those are additive inverse. So 3 plus negative 3 would equal 0. That's the additive inverse. So negative 7.5 plus would give you 0. That would be the additive inverse. And then the bottom one is an order of operations example.